Hello, hello, good morning. Happy Thursday. Almost to the end of the week. Let's see. Today the plan is to record a video for that sort of like addendum for the ECS, like an alternate sort of like run function we can do that makes it a little bit nicer for the user. And then we'll sort of like go back into the Rust standard library. I'm getting some ideas for some like other projects to do, like whether or not I want to do a project or like another tutorial. I've got some ideas. They're coming along, but I still got some like planning to do for them, so that the Rust standard library is like the perfect. Okay, I'll do that while I'm still planning. All right, so until then, let's go ahead and get this started going. All right, so you're running. I don't know why this constantly failed. I have get installed. I guess it just hasn't finished spinning up the code space, but by the time it wants to run that, seems a bit odd. But if we come into here, I should be able to do a cargo test, and that should all work. Along with those errors, which are totally understandable because we need to do them. So create entity, so we've left that empty there. And then down here we have what this is going to be. So I've actually got the tests in full here. And the ref mute, okay. So what do we need to do? This one, all the normal stuff, create a new query, and then run gives us, right, a vec of these query entities. All right, so let's just do this and see how it works up. It's gonna be the first recording in the morning, so it's gonna be very interesting to see how well or not well this works. I'm turning off the music for this one because that is one of the feedback that I got, is no music on the recordings. So here we go. I've got a little bit of an addendum here for the ECS course. So SOS, a community member who has taken this course and chatted with me on Discord and came up with this alternate strategy for doing queries. So I wanted to implement this in, but also give him full credit. So in the code, I have the comments of his comment and also a link to his GitHub in case you want to go check him out. All right, so what exactly is the suggestion here? Well, it's to make the queries a little bit nicer. If we take a look at this example that we already have written in a test, we do the first sort of like setup code is all the same, where we just create our entities, we register our components, and then we register the components, we create the entities. That's pretty much it. Now here is where we start to create the query. So creating a query is normal, like everything, but then here is a little bit different. We do our query with component, and that's fine. But then I'm gonna have it do run entity. Now, obviously this could just replace the run method, but I wanna keep the one that I have in the course the same. So I'm gonna create another run called run entity here. And when we do that, we're gonna get back a vector of query entities. Now, from that query entities, we're going to we're going to loop through them, and then I should be able to just run a get component on it, hand it the type at that point of time, and then I've just got a ref to it that allows me to just start working with it. We have a very similar thing down in the mutable version down below. So let's start with this. So obviously, if I run this test, it should fail because we don't have that code actually running yet. So method not found. Let's go fix that. So this run entity method is not found. We're going to go up into query up here. And I'm just going to find the run function where that ends. And we're going to create a pub function run entity. Now, if we remember correctly, this takes in nothing at all, but it's going to return this vec of query entities. So you're going to take in just a reference to self. We're going to return a vec of query entity. And that's going to be that. Let's go ahead and just return an empty vector just to make that happy. All right. Next up, well, this is assuming that the query entity has an ID on it. It also has a get component function on it that takes in a type. So let's go ahead and implement that as well. I actually have a completely different file for that here in query entities that's inside of entities already set up for us. So we know that we need an ID. This is probably going to be a usize. I'm thinking this is the index of the arrays. Let's create a constructor for this. And also we need to make sure that we have this get component. So pub function new. We know we're going to take in an ID, and I have an idea that we're going to need to have the entities themselves to do the sort of like the gets on. So we're going to have to not only take in the ID, but the entities, which is going to be a reference to entities. Now, if we do that, we know that we have to have a lifetime here. So let's go ahead and register that, which means you need to have a lifetime here and here. So pub function new, we're going to have our ID come in, which is going to be a usize. And then we're also going to have these entities come in, which is going to be the entities. We're going to return a self. So with the ID and entities. Okay, easy enough for that constructor. Then our other function here is this get component that is going to return the actual thing that we pass in. And it looks like it's going to return a ref to it. So let's go ahead and create that function. So pub function get component. We know that you're going to take in a type. Now this type has to implement any because we have to get the type ID in order to properly, grab that component and get the information out. So we'll just go ahead and set that up there. We know it's going to be a reference to self. I don't think I need anything else in here. Now we're going to do all of the borrows and the downcasting and everything else. We know that the sort of like the thing that we get at the end of this is going to be a ref. So it's a ref like this that has a T. Okay, so this is kind of what we need. It's going to yell at us until we actually implement this. Oh, we need to pull in any so it knows what type that is. And now it's just yelling us that we're not actually returning this thing. We see that it's okay. It's trying to do this. There is a question mark here. So we are going to have to do a result on this. like that. Oh, and we need to make sure we pull in a error result. I'm actually stopping that. I don't really like this so far. I feel like the way I'm going through it is I almost want to redo the test at the same times. Hello, Dota 2 Attitude. How are you doing today? Also, my tea finished brewing. I need to get that out. I want to try that again. Help you process something? I mean, I can try, but no guarantees. No promises. Okay. Now, did I store that? Because I have these here. In your local dev group, a company said we have no good resumes, applications, and rah, 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 rah. Oh yeah, I've heard that story before from many other companies. So you send the resume, the hiring manager replies back with, "We'll likely interview you next." Okay. I have an idea of where this is going. It's been 3 days, nothing else. I wish I could tell you exactly why companies do this. I remember there was a time when IBM, if you're overreacting, probably not yet. It's been 3 days. It's so I guess I mean so my rule of thumb, if it's been a week, I reach out and ping them. Say like, "Hey, are you still interested in interviewing me?" Otherwise, I'm gonna just like move on to something else. So I guess like I guess that's what I would feel is like pretty soon you could probably reach out to them and like ping them, and just say like, "Hey, this still moving forward? Are still good and good?" Yeah, and that's that I wish I could say like that's not common, but like it happens all the time. I try so when we're hiring in the past, I tried to be really good with being on time for like scheduling interviews, for like getting back to the applicants and letting them know. Like I'm really big on like, okay, we're letting you know that we didn't choose you and not just hanging you out to dry, because that's a terrible feeling when you're on the other side of the desk. So I don't know, like, yeah, it's so this is a human problem. We humans tend to be very bad at setting expectations, and sometimes we like people to feel happy in the now, and then we don't give them what they need uh instead. Does that make sense? So like instead of telling you what the actual process was, he told you what he thought would make you happy. Um and that's I think that's because telling you something that like they think you might not like as much uh makes them feel bad, and it's kind of hard to do something if it's going to make you feel bad. It takes inner strength to do that. Yeah, I totally get that. In a Discord that I was chatting with, oh, sorry, in a Slack that I was chatting with this morning, I was reading about somebody being told that they had to schedule 30 hours worth of time slots, uh, and then the company didn't get back to them for 3 weeks, of which one they're going to take. And it's like, well, you need me to like block out 30 hours of my days for a week? Come on. Um, yeah. I wish I could say that this was not normal, but I think it is the normal. Yeah, no, I totally get it. I totally get it. Rant away. Rant away. It's a good place here. We will we'll take your side. All right, so let's do the tests here. I'm going to go ahead and turn these back on. Cut you out like that. Okay, so gonna have there like that. That's gonna be good. And then I want to do is in the query, let's actually just remove this run entity. Let's remove all of this. Let's actually just delete this file. Let's see, anything else? I think, oh, entities. Query entity, we need to delete that. Oh, and then the custom errors, there is a custom error that we did. We can delete that. Okay. And I think that's it. So this is we're gonna start with this, and then it's gonna like, well, let's now build this out. And so that'll probably be most of today, but we'll do it as sort of like a long form lesson video. We already practiced this yesterday, so it should be fine. All right, let's try that. I don't need you. Delete all of you. All right, let's try this again. Hello and welcome back to the ECS tutorial. I've got a little bit of an addendum here. So community member SOS recommended an alternate query run function that would make it a little bit easier for the user in their ECS systems that they would create in the the app, whatever game or other system that they're going to use to create for this. So in the conversation, this is sort of what it's going to look like. Basically, we return some kind of struct from the query that then we can run a function like get component on, and then it would provide, like, then you just get the component right there. It would do all the downcasts inside of it. So I want to implement this into our system, sort of like next to what we have right now as like an example of how this works. However, if you like to go check out SOS and see their GitHub, I have a link to that inside of the code base, which is now going to be there. All right, let's go ahead and get started by creating a test for this. So first one is, this is going to be a get a reference. That's going to be the query, just to get a reference only. So this is going to be query like entity query for entity. Just call this a ref. We're going to turn a result, and we don't really care what's inside of that. All right, so first things first, we need to sort of like just spin up the entities and get that all set up. So let's do a let mute entities equals entities default. We're gonna need to register some components. Entities dot register components, and let's do a U32 and let's also do an F32. So we'll have two of them there so we can make sure that our sort of like query does the right thing and doesn't like somehow miss some steps. Okay, so once we've registered those components, we should be able to now insert a couple of entities in. So let's do entities.create entity with component. We just need one component each for these. So let's say that's like health. So we have like a 100 U32. I don't think, does he return? You do return a result. Okay. And let's do another entities. Create entity. So we'll just do one of each. So with component, and you'll be maybe like I don't know, like how hard you hit or something like that. So do like a 10 .0 F32. All right, so we've now created our components. We should be able to query for these out of the entire system. Okay, so we know we want to create a new query. So let mute query equals query new. We also know this takes in a reference to the entities, and that gives us a query here. Then we want to sort of like configure our query. So that's going to be our query dot with component. Now let's just only search for this U32 here. So U32. That's all we want to do. And now normally we'd be able to do like either another with component or just this run. So let's actually, instead of run here, let's create this like a run entity. So it'll be, sitting alongside that run function. And then I don't think we necessarily need to pass this anything. It's probably going to return a run would normally return a result. So let's go ahead and return a result here also. Now, if we do this, we now expect that we're going to get a vector of like the full entities that's going to give us, well, whatever we need out of here. Okay, so let's do let entities, like entity components almost. It's really just sort of like a wrapper that's going to give access to these other things. So let's do entities equals. Now, what are we actually going to expect to get out of here? Let's go ahead and set this up too. We know we're going to want this to be some kind of vector. And we know you want to have some kind of like entity in here. So let's call this like a query entity. Now that doesn't exist yet, so that's gonna be fine. But let's like run through like how this entire thing is gonna work here. Okay, so we have our query entity. We're running the entity that gets us this vector of these. Now I should be able to loop through these. So for entity in entities, I should be able to take ownership of these because this query is really going to just do some stuff behind the scenes to grab like the references or the mutable references. Okay, so we're going to loop through this. Now it's going to be this query entity. We still don't know what that is right now. But for each one of these, we need to have the index on it. The index on it is important because that allows us to sort of like grab what the very like the things that we need out of it. So I think that's going to be helpful. Let's double check that we have the ID. So we're going to assert equal that entity.id is equal to, well, we know that this is going to be a 0 because it's the first component out of here. Okay, so that gives us that. Now the other things are, we want to be able to run this function to sort of get the component. So I'm going to do let probably our component. Now specifically, I want to get like the actual thing. So let's just do like a health. Now what's the type of health going to be? It's going to be a ref, because after we borrow and downcast, we just get a ref of it. This is going to be a ref of U32. So I want that is going to be equal to entity.get component. Now we have to give it in the type in order to like make sure, because if we're querying for multiple things in this query, like it has multiple components that we're trying to get, then we still need to get like each one out here. So we're going to say, I want a U32. And we're probably going to have to question mark this. I don't know if we need to pass in anything else. I think that it should store everything that it needs internally to have this work. Okay, so then we have our health. We should just assert that this is the right health. So we're going to assert equal that a dereferenced health is equal to 100. And that should be it for the testing wise. We might have to come in here and like change the little things here and there as we figure it out. But until then, we need to make these errors go away. So first, we don't have a query entity. Let's go ahead and fix that. So in entities here, we're going to create a query entity.rs. Now to make this sort of visible as a module, we have to come back here into entities and add that in here. So pub, and I don't know if this, yeah, this is going to need to be pub, so that way people can get access to it and sort of like see what that is. So pub mod query entity and a pub struct query entity. If we remember, we need an ID on here. So an ID is going to be a usize because it really is just that index. And you need to be public so we can have access to you. Back to query, we need access to this. So I'm just going to import you. And there we go. Okay, so we got that. Next up, we need this run entity method that's going to return this vector. So let's go ahead and scroll up and go add in right below this run function. So pub function run entity. We're just going to take in a reference to self and nothing else. We know we're going to turn a vec of query entity. And so let's just return an empty vector for right now, just to make that that error go away. All right, what's next? You also, oh, it's not just run entity returns a result. So let's go ahead and make sure that we're doing that correct. So you are a result of this. Okay. And you need to be an okay. Wrapped around this vector. All right, what's last? And then we need this method get component that takes in a type and returns this ref. That might be a little bit more interesting to do, but let's go ahead and implement that. I don't actually think I need you. I just, okay, so we know we need a pub function. What was this? This was get component. Get component. On top of here, we need just a reference to self. I don't think we need anything else, but we did notice that we need to take in a type. Now that type is going to have to implement any, because we need to get the type ID off of it to get access to the components from the hash map. We also know we're going to have to return a ref that's going to be this type T inside of it. All right, so that works. Now let's just go ahead and just mark this as to do for right now, so it won't yell at us. Let's bring in any so it knows what that is. Obviously this will crash if we try to run it, but oh, and it's a result off of here. So it's not just and ref, it's a result, which needs to be an error result. And then that's going to store this ref inside of here. Okay, so no errors showing up here anymore. Let's go ahead and now just start like actually running this and then fixing things as they sort of come up. We know we're going to get into a lot of troubles because we don't actually have anything showing up here, do we? So if I run you, well, actually everything passes, doesn't it? It passes because we have an empty vector, meaning it never goes into this loop, meaning that never actually hits these asserts. Let's add an assert here. So we're going to assert equal that the entities.length is equal to 1. So that way, in case we don't have that there, we're not like querying for anything at all, it still fails on us, which now it is. Left and right do not equal. Perfect. Okay, so now we actually have to do the query to get this this query entity back. So let's go into our query up here, and we can kind of just steal a bunch from run. Let's just copy this entire function here and just sort of like see what we need to get, because right now we need to return a result with not this tuple, but rather the oh, what is it called? It's going to be the this query entity method. Okay. Okay, so first we get the indexes. I think that's exactly the same. I don't think we have to change anything at all here. We're going to get the vector of the indexes. However, I don't think we need to start collecting the results here. And in fact, thinking about this a little bit, we don't need to get the type ID to actually get the components out. So I don't think we need to do any of this stuff. Now I have this collection happening. And then looking at this, I don't think we actually need this to be a result. I think we can actually get away with just the plain vector here, which means we can just return straight from this. We'll have collect, turn this into a vector of query entities, which means we need to put that in here. So instead of this index here, we're going to do a query entity. Now, we need to like store in the ID, and I could just put in ID is the index here. That should work, but I also want to clean that up. Let's verify that that's working right now. Right now, let's an entity. We're going to remove that question mark, and you're happy. But I'm kind of more of a fan of using a constructors for this. Let's create a really quick one here. So pub function new. We're going to take in the ID, which is a usize, and we're going to return a self. Self with the ID. Okay, nice and simple, but that allows us to up here in this sum, we're just going to do a new and pass it in the index, and that's it. Now that allows us to return this because the collect takes all of these sums from the filter map and turns it into the vector of query entities. So far, So good. Let's come back down here and rerun this and see where the next thing we need to fix is. Okay, so now we get this not yet implemented. So what happened? We do the query. We got the one thing that we're looking for. So that's great. Then we get our entity in entities. And okay, so we got past this. Now get component, we try to run that, and that is that's not yet implemented. So we need to fix that now. So let's take a look at this. We need to do entity, get component, we pass in the type, we get a result, and then this refs. This actually gets the actual thing. And hey, I just paused it really quickly. Coding Garden fan, hello. You know what I forgot to do? I forgot to tell Nightbot to restart the timer for I'm recording. So I'll enable that right now. Hello. So yeah, I don't have it today. I am recording this video for like an alternate way of doing queries in the ECS course, and then we'll be getting back to like normal stuff if we have time. We'll see how long this takes. But yeah, that's what's going on. I am going to get back into pause now. I know, a new video for YouTube. All right, here we go. All right, so let's go ahead and now implement this function properly. So if I want to get the component, what do I need to do? Well, I have the ID. So I can like grab the ID from the actual component vector, from the component's, vector. But I need to actually extract that out. So how can I get access to the entities? Well, we're creating the query entity. So I think actually we can get away with just storing the entities in here. So, and this doesn't need to be public. This can be just like private to query entity, and it could just be a reference to it. So we're going to have the entities, and you're going to be a reference to entities. Now, of course, if I do a reference inside of a struct like this, I need to have some lifetimes. Let's go ahead and set them up. So the a lifetime there. Let's go ahead and also implement some lifetimes here. And we're going to have the entities, which is going to be a reference with this lifetime for the entities. And we're just going to store them inside of here. So this will be happy here, although up here, we now need to also pass in the self.entities. Now, notice like we're running stuff off of self.entities, but because we're just running it on a immutable state, which is just a reference to it, and we're not mutating anything at all as far as Rust is concerned, that this is perfectly legal, and the borrow checker is going to be happy with us. So back to our query entity. Now we're storing away the entities, but I think this is now everything that we need to get. It's just yelling at us that we're not using it yet. Okay, fine. So what do we really need to do here? First of all, we need to get the type ID so we can query for the vector of components. So that the type ID is going to be equal to, we're going to do type ID of, pass it that type. Okay, so now that we have that type ID, we should be able to get the actual component out. So let our components is going to be equal to self.entities.components.get, pass it in a reference to that type ID. Now this is going to give us an option here. So what do I need to do with this? I want to kind of convert this into a result, so that way we can turn an error in the case that for some reason the type that we're passing in isn't correct, like isn't something that we can actually get. So with options, we can do that with an okay or, and then pass it in some kind of error state for this. Well, let's actually go to our custom errors and add in a new custom error here. So we have entity does not exist, component not registered. Actually, that one might be right. We're attempting to reference a component that wasn't registered. So let's do this one, component not registered. So back to you. We're gonna do a custom errors, component not registered. And we don't need to do anything else special with this, but notice that this is now attempting to return a result. So I'm gonna go ahead and question mark that. And so now we have a reference to these this vector. Okay, so now we can get the specific component out that we're looking for. So let component is equal to the components of self.id. So it's nice that we like stored that away. We don't have to ask for it separately here. Now that gives us another option in here because each of them have these options, but we know that it should definitely exist. There should not be any like way that this fails, but just in case it does, because sometimes things that are impossible tend to happen. Entity does not exist. How about component does not exist? So if we do component does not exist, and then we add in this error, attempting to get a component that does not, I guess component data does not exist, maybe. Get component data that does not exist. We're gonna now convert this option into another result here. So let's do another okay or, and this is going to be that custom errors, component data does not exist. And okay, so that gives us this RC now. Now I need to borrow off of the ref cell to get a ref. So I think we can just go ahead and borrow straight off of here. That gives us this ref dine any. We do need to do a downcast for this too. So you're now a borrowed component. And then we need to figure out how to like, well, I can downcast. That's no problem. Let's go ahead and just do let our component equals the borrowed component downcast ref. We do need to tell it what we're downcasting into, which is why we have this type here. That gives us another option. So let's go ahead and we can unwrap it, or it's like maybe the wrong type. We can give it another custom error here. So attempting to downcast to the wrong type. So let's see. Downcast to wrong type. We'll do an okay or custom errors, downcast to wrong type, question mark that. Okay, now I have this reference to a T, but I need actually to have it be the ref of the T itself. If I try to do the T itself, it's going to yell at us that, well, we can't really do that because then it's like we're getting ownership of it, and it's a sort of like a messy thing. So I actually want to keep it as the ref. So maybe this isn't exactly what we need here. And there's a really cool sort of like system that we can do here. let's see. So after we borrow, I want to maybe not do the full downcast just out here at this level. Let's go take a look at the documentation for ref and see if there's anything that can help us out here. Specifically, this map I think is going to help us out. So makes a new ref for a component of the borrowed data. The ref cell is already immutably borrowed, so it cannot fail. It's an associated function that can be used, so it's basically a static method essentially. But it allows us to sort of like clone things over without like it's nice. It's I don't really know like the best way to sort of like explain what's happening here. But let's go ahead and use it, and we'll see how nice this actually is. So instead of this component being done like that, let's go ahead and reset this a little bit. We're going to just straight return from here. So we're going to get that okay for the result. And then from there, we're going to take this ref, and then we're going to map. Now it takes the original, which is this borrowed component, and then a callback function here, or a closure. Okay, so what do we want to do here? We need to basically take our borrowed component and we're gonna get like the thing in here. So is this anything? So we need to downcast it at this point. We're gonna take this, whatever it is, this data, this any data, and we're gonna downcast ref, tell it to go into this type T that's passed into us. And then at this point, I think we don't have a choice but to unwrap it. Because if I try to do like a bail or any other like custom errors, it unfortunately is going to error out to this method and not up to here. So it's an unfortunate unwrap that we haven't figured out how to get around. So if we save you, let's go ahead and see like what problems we're running into. Cannot move out of index. Okay, so I can just get an as ref maybe. At this point, I just getting a reference to this should probably be fine. This borrowed content. Expected to destruct a ref, found a reference. Can I just dereference you? And then cannot return a value referencing temporary value. Oh, okay. So cannot move out of the borrowed content. Oh, there's a method that we can use, I believe. We have this okay or I think it's like an as ref here. That makes it happy. So we're going to take this components that gives us this option with the RC ref cell. We then do the as ref, which moves things around. So it's now this option with the reference on the inside of the RC. Then we can do the entire OKR to convert this option into a result, which then we can then do the borrow here, question mark and borrow. So that seems to be working now. We don't have any errors. Let's go ahead and come back to our test and run this and see what works. Well, it's actually passing. We're now able to get exactly what we want. Now, just to make sure that we're not like, we didn't do something wrong, I'm going to go ahead and change that to 101 and we should get an error. And we do. So we're able to actually just get the full query, get the full item out that we want at this time because kind of what we're expecting here. So it makes querying a little bit nicer from the user's perspective. Okay, so that's for ref, but what if we want to do mutable? What if we want to change things? Let's go ahead and copy this function again. And we're now going to add a mute version. Now we don't need to change anything with the query itself. Everything is going to remain the same up until, let's see, got that somewhere down here. So we're looping through our entities. We assert the ID is 0. Okay, we get the health. Now we assume that you should be a ref mute. We're gonna get component mute. With that U32, that should be the same. We should assert equal that you're 101. Well, let's actually let's make a change to you. It's okay to like make sure. Okay, you're 101. Let's now change you. So if I do a dereferenced health plus equals to 1, so now you should be 101. Now, just to make sure that this actually is like sort of really happening behind the scenes, let's just do another query again. And so I'm going to repeat this query here. So we already have our query here. I didn't shadow anything. So I kind of want to just run you again. I don't need to assert that we know that you're working. We're going to do another loop through here. Don't need to check that. We know you're working. So for this one, we're going to get you as just a ref again. So get component, and then we're going to assert equal that you are 101 now and not change you again. So that's what we want to do here. Now you're yelling at us that get component mute doesn't exist. So let's fix that. So pub function get component mute. I think actually a lot of this is going to be the same. So let's actually just copy and paste this and see what we can do. So to begin with, get component, you're going to now be a mute, a result. So we're going to have a ref mute here. Instead, we do need to pull in this type so it knows what that is. The type ID is going to be the same. The components is going to be the same here. Now the borrowed component, this needs to be a ref mute at this point in time. So as ref, probably as mute. And we need to borrow mute here. And then down here, we need to do a ref mute map. Borrowed component, we get our any. We need to downcast mute. And these components, okay, our components need to be mutable too. Cannot borrow dereference components mutables behind a let's see, as mute. Okay, or we do the borrow mute there. You don't actually want to be, do you need to be a get mute here? No, because we can't actually borrow this as mutable. So we can't do that. So you're just a normal get. Let's come back. Let's go through one at a time. Maybe it's not quite as simple as just like going in and changing everything around. Let's actually think about what we really need to have happen. So we have this borrowed component. So we're going to take the components. We're going to take that ID. We have this option RC ref cell. This all seems to be fine at this point in time. Now, as mute gives us a mute RC. I don't think we need to do that. I think this can stay as an as ref here, because really we're just going to borrow mute at this point in time, which gives us the ref mute here. And then we're going to do the ref mute map, and this seems to be working. There's no errors here. Let's come back to our query. You are yelling at us because we can't borrow health as mutable because it's not set as mutable. Let's do that here. And you seem to be working. Let's go ahead and run you. And it passes. So that means that we are able to sort of update and mutate that variable, that data inside of the components without having to do all that ref mute stuff in the system itself, which is really nice. Now we have a bunch of sort of like shared code here. I wonder if there is a way for us to sort of like have this be like sort of similar here. Let's take a look and see what we can do. We have the borrowed component. Now this is going to be a ref, and this is a ref mute. Does mean that as ref, okay, or, and then a borrow. Well, the big difference is this borrow mute is here. So we may not be able to change this line and down on each function, but these two lines are exactly the same. So I wonder if I can create like a get components. So sort of like query for components, get them internally. Let's do a function, maybe like extract components. We do need this T. We're going to implement any. We're going to be a reference to self, and I don't think we need anything else stored in. Now we're going to return this sort of nasty thing here. So let's go ahead and write that down. So you're going to be a reference, and that may or may not work out well for us, because if it wants it to be a reference to a vector, we'll have to see. This may or may not work. Have our option, which then itself has an RC, which then that self has the ref cell, which then that has the dyn any. Okay, so I want to just take these two lines, extract you into here, and let's see if we can just do that components equals self dot extract components. We do need to pass in this T, and that's it. No, this has to be we have a question mark here. So we're gonna have to question mark that, which means you need to be a result here as well. And you, cannot find the RC type, so let's import RC and ref cell. And you are mismatched types. Okay, so we have this components coming in here. Let's go ahead and actually, I don't know if I need to do anything more than just return the result of this. All right, so try expectation to have incompatible types, expected this result with the vec. So it looks like we have reference to the vec, then an option, then an RC, a ref cell, and then a dyn any. That looks appropriate. Oh, and then error report. I do have error result. That should work out here. Now oh wait, take away that question mark. And then okay, so we need to make sure that you are exactly what I want to be. So we need to change you into an okay or else, because if I try to just do like an into here to convert it into the appropriate error result, it's going to yell at us and say, hey, if we're going to do any like function calls or any kind of logic in here, we should do the okay or else. So let's go ahead and change that into there, and then you now will work. So you are a complex type. So it doesn't really like this. Let's go ahead and change, like, we're going to create our own type in here. So we're going to do a type. This is like an extracted components maybe. So like extracted components. That is going to equal to this entire nasty thing. Then from that, we can now replace you with an extracted components. All right, so now we can see that we got that out, extract components, and there's our type coming in. So we can replace that down here as well. So let components is equal to self dot extract components, pass in that T, and question mark it. And we're good to go. You are upset. Oh, missing lifetime. I guess, do we have to do a lifetime here? We do. Okay, and then it should be happy. Let's go back one last time, run this test, and we'll run the entire suite of tests to make sure we didn't break anything at all. So that passed. And we're just going to open up a terminal and do a cargo test. Everything should pass now, and it does. So which means we've implemented a much nicer interface for queries that sort of like runs along the much less nicer default way that I had in the course. So next steps, if you want to sort of like try to make it even nicer on the user side, perhaps looking into creating some macros. That's outside of the scope of this course, so we're not gonna include that here. Maybe in a future course we'll talk about macros. And then perhaps like going right through and looking at some of the other methods, other sort of like areas that we're using things, and how can we clean them up, make it a little bit nicer so we don't have to do downcast and other things inside of the user's code. Anyways, thank you so much for watching, and I'll see you in the next video. Bye. All right, and finished. Let's go ahead and name that before I forget. That was a doozy? Yeah, that was a long one. Hello, Medium Q. How are you doing this morning? This was sort of like addendum. Making a nicer query. All right, so I'll upload that probably tomorrow or so. I can't actually upload those now due to the Twitch restrictions. Morning and still alive. I mean, yeah, it is morning, and I suppose if you're typing this, you're still alive unless you wrote a bot. All right, so what? I guess there's I don't need this anymore. Was there anything else new? I think I'm good here. Okay, exploring the rest standard library. So, oh, you know what I want to do? I don't know why Git doesn't like these in here. Yeah, okay, enable Git. Okay, so here is good. So this is addendum, adding a nicer query. Thanks to @ there. And up you go. Okay, so I can close you down now. We have another one here. Let's go ahead and add another code space. This is going to be Brooks builds the deep dive. Yeah, exploring this Rust standard library. We can start doing this up in the code spaces too. Make it a little bit more sort of like standard when it sets up. Especially if I switch back and forth between different sort of like services. It just always runs on Linux now, which is nice. Of course, because we're setting this up, we have to add in all of our extensions again. Talgobit, hello, and welcome Raiders. Talgobit, oh, Raid and Run, need to go put your brain in a dishwasher. I suppose that is a thing to do, but hello, welcome everyone. How are you all doing today? What was Talgobit working on? Hello Zap, Arcanes, Destruin, ES. You're working on Linux? Hello VR Linux. Oh, Blind Venat, he was ranting about Windows versus Linux distros and stuff. Got it. Okay. That is a thing. Okay, so we do remember we need to do a Rust up update to get the latest version of Rust inside of code spaces here. In spite of cross term. Oh, that's too bad. I can't remember. So I can't remember what he's using behind the scenes. Like, is he on Windows, and then using like WSL? I'm on a Windows computer for like best use of OBS, but then I got access to code spaces and I haven't really been using it too much. But we started at work, and so I decided to like start playing around with it more here. And I realized that I can get this Code Explorer thing going and actually just launch a code space from VS Code itself. So this is my local VS Code, but I'm sort of connected remotely into the code space, which means this is an Ubuntu Docker container, I think, that I'm in, or VPS. It's hard to tell. He's on Arch. Oh, nice. OBS compatibility for Linux feels native. Yeah, I kept on, well, it's been a while. So like it's been a year or so, but it was causing me to have weird issues. Like it was crashing all the time, especially when I try to program and stream at the same time. It just wasn't working as well as like the Windows stuff does. It might be a good time to sort of like look back into it. We'll see. Have I seen that GitHub has new colorblind themes? I did not see that. That might be interesting to look into. But this is pretty nice. So I've just updated to Rust 1.55. So I should now be able to do Rust Analyzer in here. Now you are... Okay, so I have Rust Analyzer installed locally, but it's telling me I can't do it unless it's installed in CodeSpace. So let's go ahead and install it over there. So this is sort of like one of those interesting things that if you do use code spaces, you need to reinstall all of your extensions for every code space, which I suppose is the reason why they want you to like constantly turn on setting sync, which I just don't do. I don't feel the need for that. All right, so you're installed. I should be able to now come into our examples. Let's just take a look at some of these. And if I run you, yeah, okay, so all of this stuff is working. Exit that terminal. Let's come back you and take a look at what we got. So I think we want to go to our explorations, the deep dive. Right, we're going to look at index mute. Let me guess, it's code server in a Docker that you can access from a web browser. Probably, you can definitely access it from a web browser. So if you have access to it, you can go to any GitHub repository that's open source, or if your team implements it, then you can go to any private for that team repository and open it there. So here's this platformer with level editor. It's an open source project. I can click on this, go to code spaces, and create a new one right there. So it's nice. Index mute. So we're coming over here. And I have been checking around. I've been playing with it at work. So we have a team at work for our private repos. It's so far not too expensive, surprisingly. So I've installed live share on it, so my coworkers can actually live share in. And so far, it's really nice. Maybe I'll do like an entire like sort of like tutorial on like setting that up, or it won't be really tutorial. It'll be like an introduction, like show what it'll work at. Oh, code server. This is for setting up a VS Code in a browser, right? Yeah, I totally saw this before. Yeah, run on any machine and access it in a browser. Yeah, I've seen this, but I've never actually used it. It does look pretty cool. The live share gives some other nice things that we don't get from that right away. Like, for example, you can run a web server in it and then export the ports, so that way you can just sort of like see what you're working on, because that kind of matters when you're working on web stuff. Okay, so we're going back to index mute. Now, we took a look last time at what was it? It was just index ref. It was ops index. And we noted that we couldn't really, like, we could do some interesting things with this, but we couldn't really do like really amazing things like for like the ECS library. It would have been nice to sort of like set this something up for us to just like grab it out of there, but it's not as awesome as we were hoping it would be. But index allows us to like use this syntax. So let's go ahead and come back here. Do a actually we should just do this inside of the index. Trait index. So we're doing impl index for location. So we have this, it's sort of like a weird way of doing this, I know, but we have like a struct location, which is a struct. It has this X and Y, and I am actually saying, give me index of 0 on this. And that gives me the X. Kind of weird, right? Now I could pass it in like a character or anything else. We can then set what we're indexing with. And then we're getting a reference out of here. So what if I were to do a mutable version of this? But maybe we'll do like the character so we can get like the X and the Y. That might be interesting. So let's create a new file here. We're gonna do trait index mute. So we're gonna have another location with an X, and this will be our, we'll just use F32s for these. 32. Then I want to create that location here. So maybe we're something like, I don't know, 50.0, 100.0. And for some reason, to make these things a little bit nicer, instead of like location.x, I want to be able to do location of, well, these are private fields, so I can't even do location.x. I don't think I can do something like debug location.x. That should yell at me. Field is never read. That's fine. Oh, I guess just because I don't have them as public, I still get access to it because it's still in the same file. That's interesting. Now, normally, if this was in a different file and I'm using like an entire other module system, I wouldn't have access to X, which I guess makes it a little bit harder to sort of like use in this as an example here. But what if I wanted to do index and pass it in the character X? You're going to yell at us because you can't index. Now it's not even telling me, hey, try doing something, like try implementing index. So let's implement index mute here. So I want to do like let maybe like let this location. Oh, okay. I want to mutate it, right? So I want to do mute location of X plus equals to 1.0. And then I want to just sort of like debug that out. So we'll do a debug of location to see that. So we need a derived debug here. Now you cannot index into this. Well, that's fine. Let's go ahead and fix that problem. So index impl index mute for pair for location implement our missing members. Okay, so we have this index mute here. We take an immutable reference to self. We get our index, which is a character. We're going to return this self output. Kind of surprised we don't set a self in here, like an output in here. We'll see how this works. So we're going to match on index. So if you're an X, then I want to return a mutable reference to self.x. And if you're a Y, I want to turn a mutable reference to self.y. And if you're literally everything else, now it's sort of like assumed that you can fail out of here. So we can just sort of do a full panic. And we're gonna say, sort of like out of bounds. So like location doesn't have anything, like I guess out of bounds, like location out of bounds, index out of bounds. Now, what are you upset? The type location cannot be indexed by a character. Oh, so I can't do that. So can I only do here that I can do other, let's normal index. So I can do this side here. Oh, do I have to? Oh, maybe I do have to implement index first. So impl index. Yeah, you're probably right. Index char for location. So if I do that, implement assuming members, that's probably what it is. So now this output is being set here. So you're going to be an F32. And then you are going to be match index. So if you are a X, you're going to be just the reference to self.x, and Y is a reference to self.y. And anything else is a panic index out of bounds. There we go. Okay, thank you, Nowis. That is exactly what it is. Don't know where that got in there. So now I should be able to run this, and we should get that X is now 51. So really interesting that we need to implement the sort of like the non-mutable trait version in order to get the mutable version. I don't think some of the other ones we haven't needed to do that. But in the case that you want to index things like this, you can. Now I don't have any like actual real ideas of when to use this. It is nice to know that you can. Let's go ahead and make some notes down for this. So we have so like the big thing here is when implementing index mute, need to also implement index. I don't know if there's anything else necessarily. We can just give our example. It's like pretty standard normal. You have to panic. There is no way to do a result in these. But that's sort of like normal arrays or vectors. If you go out of bounds, you just get a panic. Okay, what else? They give us the examples there. Okay, required methods. Is that index mute? So basically, requires, let's see. We already have like the other one, but it's like take in the index of the type set in the impl, and then return the output type that is set in the index, sort of like method or impl. This method can, and I guess like and must, or like I guess can. It's may panic. So can panic if necessary. We can also just have like a default, right? Where we just say, hey, if you can't find anything, here you go. Here's like, you know, the first element of the whatever it is. And then we see our implementers. So interesting. Once again, like, I don't know how often like I would use that myself, but it's there in case we need it. Perhaps someday I'll like be like in a weird situation where it's like that one thing is going to really help out a lot. Coming up next, we've already done into iterator, so I don't think we need to do this one again. We've done compare ord, partial equal, partial ord. Looks like next is gonna be our try from. And I hate to do this, but it's 9:25, which means I need to end the stream so I can head to work. So what I'm gonna go ahead and do here is end the YouTube recording, and then we're gonna go find somebody to raid. So thank you everybody for watching, and I'll see you in the next video. Bye.